Hey guys, me Keith back with another repair. Back on the bench with another MDS board. Nintendo versus board meant for the red tents. This board you can see is in progress. I wasn't going to make a video, but now I'm going to make a video. The sockets were completely corroded. The CPU, PPU, the ROMs, the RAM sockets. So I went ahead and took it off, but the worst part was a lot of these ICs were just completely rusted. They had so much corrosion on everything, all the legs. They were fuzzy, and they had the deep brown rust surface kind of rust that you see on cars. So what I'm going through now and doing, I have a little metal brush, and a lot of these vias are corroded over, and I'm just going through. I'm kind of getting aggressive on it. There's so much corrosion, but I'm doing like a pre-cleanup before I take alcohol. We have everything desoldered. Some of the up pads on the upside got destroyed, so we're gonna go through. We're just gonna clean everything up. Then we're gonna go through with the solder gun, probably re-tin this, look for broken traces, lifted pads. But right now I'm just going around these vias and just getting that heavy corrosion off and some of the discrete ICs. So we're just going to go through, scrub it up, and see what she looks like. I almost made this one a parts board, but I think I can fix it. And I did see, I think something was dropped on it too. I think there's some broken traces up here from some damage or something. But I'm going to go through, I'm going to get all these, just try to get all the corrosion off that I can without getting too crazy. This is a pretty hardcore brush. This is steel brush. So, I mean, you're going to lighten up the solder mask, but you're also going to get right down in there and you're going to clean a lot of that corrosion off. I mean, really, I'll probably take these caps out too. These are for the power. These are voltage filter caps, just to kind of smooth the 5 volts. So might change those. I don't know, that one looks pretty grungy. But okay, let's get this thing cleaned up, and I'll cut back after we're cleaned up with the alcohol and we kind of find the damage here, and I think there's going to be some repairs here. Okay, just a little progress check-in on this board. So I got it all, I have it all cleaned up. I had to take that grime off in several layers. So there were trace repairs. So I had 2 trace repairs here. There was one here, one here, one here, and they were both sides. So there was some board repairs, some trace repair, but I checked everything continuity-wise. Should look good. Still have to put the bigger CPU, PPU, and ROM and RAM sockets in, but I did get everything replaced from all of these guys I pulled. They're just super nasty. They are just super nasty chips, and we'll clean them up and test them, but I don't know if I'm going to put them back in these sockets or not. So far so good. I just found, so I ended up pulling this transistor, 2 capacitors that I have that will populate back in, and let's see, there was one more thing. The resistor, that 10K right here, 10K resistor. Yeah, this whole area just super corroded. I can't believe how nice that looks now. Even with all the new sockets, I think it'll be nice. Yeah, here's some coming up. Yeah, I already tested the 6116 and the 6164s. These are good to go. So, and these guys have no idea. Yeah, look good. Oh, we do have edge connector repair. We'll do that last. We're going to come up here and give this edge connector some love. Okay, that's it for now. Okay, just got this board. All the sockets replaced, all the bad ICs and discrete components replaced, all the repairs made on the hardware. I didn't film a lot of it, but had some trace damage here. Had three broken traces right there. Patched them up. Those look good. I was able to get those. That was probably my smallest three, like three together. Usually I don't patch these next to each other because my solder guns were always too big. I couldn't keep the heat, but I was able to get all three of those patched up. Looks great. So all the repairs were done on the part side. And then let's look at the edge connector. This required, I should have filmed this. It's a little bit fatter, but so what I did, this was completely destroyed. So I took my solder gun, the plastic underneath there was pitted. So I took my solder gun, the hoof tip, and just kind of smoothed that plastic out. Yeah, I don't know if you could do that for that, but it melts the PCB plastic or the poly. It kind of made it a smooth surface. Then I used some 2-part epoxy and some copper tape. I cut a new pad. It's a little bit wider than the others, but I cut a new pad and put a very liberal amount of 2-part epoxy under there just to kind of keep that square. Got the copper tape on, and then I able to solder a little bit of a jumper over to there, and then tin that guy. So I think it's a solid fix. That's on there good. I've already been poking around. I cannot, not that I'm trying to pry that up. I'm not. That's not gonna peel back off. That's on there pretty good. We'll see. And what else? That's about it. Probably cleaned this board like 4 times to get everything off. Got all my color pots kind of set to the middle range. Let's flip it over. I'll show you the nice, I don't know. I've the nice solder job. All the ICs, sockets, the CPU sockets, PPU sockets, everything soldered in really well. Got it cleaned up, all the flux cleaned off. Cleaned the whole rest of the board. The JAMA connector. Okay, so next, what we got here, let's spin that back around. Talk about the chips real quick. So these are the ones that were removed because of corrosion reasons. So I did test these. I straightened all the legs and tested these. These were all okay, and I found 2 of them that were bad. One of them was that 74 LS10, which is a 3-input OR gate or AND gate. I can't remember. It's a 3-input gate though. So I think there's 4. Let's see. Oh, I think there's only two gates, one on each side, something like that. And what's this other one? I can't even read it. I think this was the 157. I think this was a 157. It tested bad too. Or this is the 123. I can't remember. And let's see, I don't know if getting it in the mag glass is going to help at all, but I can't read it anymore. Okay, but we know what that guy is, and he was bad. And then, so funny enough, I had all the new ICs to replace all of these. So I went ahead and pulled those and checked them. I actually checked all these in the retro chip tester too. The only chip I'm using the same is a 74F04. Now this is a fast 04. The trigger times are faster because it's used in the clock circuits. So if you need a fast changing one, it actually says 74F04. That's fast. So then just a regular logic 04. So we're going to use this. He actually goes right here by this clock. So we'll just leave him there because that's what we're ready to do. So that's a little rundown of what's going to happen. So I checked I pulled the 6164s out, 8K by 8K, those test good. The 6116s, those test good. These 2 are from other boards. Those are bad RAMs. These 6116s are the 64s. I think these are the 64s. They're really prone to failure. These and those, really prone to failure. It's usually what's wrong with them, plus 04s and nasty logic chips. Not a lot of troubleshooting here, but this is just the maintenance before we fire up. So we're going to populate this board off camera. I've already checked it over a zillion times. I think my work is solid. Let's see. Let's get it populated and get it ready to turn on. Okay, here we go. We are all connected up. I've got, we're going to check out the reset and the power when we power on. So right now, reset's low. We should see that thing go high. Hopefully, I don't know. Let's go. Let's see. 3, 2, 1. Boom, boom, boom. And wah, wah, wah. Oh, reset went high. Man, are we not getting voltage over on the one? No voltage over here or what? What is going on there? So yeah, we definitely have some troubleshooting to do. This is side 2 is kind of booting to garbage. Side 1 is not booting at all. Here, let's, no, we got going on for power. That's saying no power. Let's check power here. We have, what the hell? I don't know if we got power over on this side. No 5 volts. That is freaking crazy. You know, hang on. There's something up with my meter. There's something wrong with, oh, no, it's resetting. Yeah, let's reset. Okay. All right, so, okay, meter. I don't think, oh, the negative's not hooked up, ding dong. I gotta measure shit. Okay, let me find a good place to put this guy. Okay. Jeez, there we go. What do we got for power? I don't think my ground is good. All right, I think we're gonna grab the tripod, I think. I'm trying to do this one-handed. We got troubleshooting to do. I'm just trying, there we go. Where's our power? Doesn't look very stable, does it? And it's pretty low. Yeah, it's bouncy. It's bouncy bad. That's bouncy bad. It's, at least with the 5 volts, we're going to turn that up a little bit. I'm going to go like 5.2. We're going to go 5 point, almost 2 volts. Let's see if that, sometimes, because what I'm doing, sometimes these won't boot if you don't get the right, power to them. Or we got broken, there we go, that's better, 4.9. Still nothing going on with side 1. Let's scope. Let's just do some scoping action before. Let's see. Is reset? Oh, I took it off. Let's, what's going on with the reset? Okay, reset's high. Do we have, well, we are firing, well, measuring address lines. We got a lot of bad address lines. Yep, we got troubleshooting to do, guys. These address lines aren't doing much. Yeah, I'm probing around on the one CPU. Now this side should be signs of life. Yeah. Yeah, these are the address lines from the CPU. Side 2. See there, we're just running down this row. I think it's starts pin 3 or 4 and goes all the way to address bit 12 or 13, 0 to 12. Yeah, we have, I wonder, where's the clock in over here? I got my cheat sheet right here. Where's the clock on this thing? Clock, 26, 7, 28, 29. You even got a clock? 29, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 9. Let's see. 29? Yep. 1, 2, 3, 4. Yep, we have a clock. It's clocking. It's clocking. What about the reset here? Okay, reset on the PPU was good. Yeah, we're not getting any video at all. Let's last thing before we cut. Now we're getting like some wavy garbage. All right, let's. I want to adjust. Yeah. Oh, I think we have a picture up there, but maybe no sync. What's going on here? We are not syncing. We are not syncing. Yeah, I think we have kind of a picture going, but no sync. But we got garbage down here, so let me get the tripod, let me get the probing around, and we're coming back. Okay, so here's what we have going on. After probing around and looking at everything here with the scope, this was all running. So basically, I could look at the red, green, and blue output. Red, green, blue, and the sync. We have sync. Ooh, I'll show you. We have sync, and this is for the top monitor, the A side. So we should be having an image. And just kind of test that theory, I went ahead, booted the game, hit the coin up, hit the start button. This is Excite Bike, and now the game will start. And here we'll get some throttle. We're overheating the engine. I can hear it. So this is playing blind. So we got to come down. I already kind of probed around. It looked like something funny and blue. Yet again, why is it always blue? The transistor, the circuit don't look right for blue. I'm getting like some really, this is blue. I'm getting on a couple of these transistors like some really high outputs, like one of them might be shorted. And how this works, how that could affect me. Because from blue, like from each color, you have that's an amp. This little crazy one right here. What is that? It's like an inverter, and part of that feeds the sync, along with the sync from the CPU. Like syncs each color. So we have. So maybe if that one's all messed up, pulled crazy, but we're gonna let me get the scope out on those, and we'll find it real quick. I think it's playing blind. I was thinking maybe my edge connector didn't survive, but I think we're connected. I can kind of see a scrolling image. Like before I even saw that, I'm like, it looks like maybe there's an image there. I'll show you. Let's turn up one of the colors. Oh, it's not going to do it now, but I saw, like if I'm adjusting red, I could kind of take it up where red was a little bit bleeding through. You can kind of see a wavy image. Anyway, can't do it now. Definitely have garbage going on down here. Definitely have garbage going on down there. That probably is a rework problem because all these chips and everything are good. Let's get that side working first. Okay, we're back looking at the why we have no video. So we're at the MDS schematics here in the video section. So I did troubleshoot around a little bit. I checked these analog switches and the op amp for red, green, blue. They kind of all look okay, but what I really found is over here in the sync circuit, and what I'm getting ready to show you on Q1 coming in here, the emitter is tied to ground. The base carries the sync signal and goes through an inverter, and then it feeds your sync, but at the same time, it's running the control line for these analog switches for red, green, and blue. So basically, on the switch, the controls for these analog switches, we have nothing, and we're not getting any signal coming back up to the red. So that kind of switches it, but I think it adds some modulation from the circuit over here, gives it another frequency, feeds the colors. And I can show you on the good side that these have a signal. Control that, then you get a picture. So we're going to go back here. I'm going to show you Q1, and then we'll go through some of these switches. All right, I'm going to hand it off to my lovely assistant here. Thank you. Okay, let's get busy. I'm distracted by my lovely assistant here. So Q1 is right here. So let's get on the base of that thing. I'm gonna put up the schematics up in the corner here when I do the editing. Let's get this thing down to 1 volt. So you can see we have a signal coming in. This comes directly from the PPU, and it looks like that at the PPU. The emitter tied to ground, like we just looked at on the schematic, is tied to ground. But the problem is the collector is flat. So let's go to the side 2 comparison. If we look at side 2, we're kind of running. We got garbage, but we got video. So let's look at that same circuit on the running side. So we have a bit of a signal there. And then let's go to the emitter, grounded as it should be. And then the collector, check it out. So the collector actually has signal that we don't have on the other transistor. So what happens is that signal will feed 2 more transistors in that circuit, which in turn come around and feed the control lines for these 2 analog switches. So let's look at I guess red. So red here is red. Got to get on the right chip. Here's the input. Well, actually, this is one of the outputs. Call it. It's flat. The other side of the switch is flat, but most importantly, more worrisome, is that pin 13. If I can get a good connection here, pin 13 is also flat. We have nothing going on. Without pin 13 active from that sync circuit, without something here, that switch can't work. That switch can't work in here. So let's do another one here. Oh, okay, here. I was on the wrong one before. So there's pin 1. Let me turn it to 2 volts per division. All right, so we have a little bit of garbage up there. Kind of have a falling signal, but I think that's more from the capacitor. I think that's more from the circuit not working right. And then the control signal, again, see the control signal? It's not existent. So that's my quick tutorial. I'm going to change this transistor out real quick, and we'll be right back. Okay, yeah, we're cutting back, and I found the problem. Since we've been gone, just couldn't find that signal where the sync signal was getting lost or pulled down. So since we cut out, we changed the switches first, and then I went ahead and changed the amplifiers just for my own well-being. And I knew when I did that it wasn't going to find the problem, and it didn't. And so I just went back to square one, where the sync signal comes in, and it was not making it to Q1, and it can't feed and turn on the switches. So I was checking out that gate, that hex inverter gate, this 04 right here, which it was heavily corroded, and I did put a socket in, and guess what I found? Dun, dun, dun. Let's come over here to an 04. So basically what I found, pin 11 is your output, or your input, and it was it was getting pulled down. So basically what we got is a short between 11 and 12, and I found that by doing continuity. We powered off pin, oh, I'm sorry, it's pin 10, no, pin 11 and 12. Yeah, it was shorted. It was continuity between them. So what I did, I lifted that leg, I lifted pin 12 to isolate it, and guess what? We got a nice picture. Okay, so that's a long description of what happened, but yeah, there was a short between here and here. Lifted that IC. So basically, so what's going on? The input of this set of gates is not being used. In Nintendo, they left this pin 13 floating, which registers as a high logic. It drives 12 low, and then it shorted to the input of 11 and drove it low. So that sync signal was just getting drove low, and it couldn't feed the rest of that circuit. So let's go back to that circuit real quick, and then we'll move on, hopefully, to like a more permanent fix here. Okay, so looking at that on the schematic, what that looks like here, pin 11 was tied low, and that's why when we checked that Q1, we had our signal here, but on that collector, it was already gone. And I had all these theories. Maybe it was the backwards current. No, idiot. You just made a short between on your socket. So let's go ahead and try to fix it. And what it was, I'm going to hand this off to my lovely assistant. So the pad was gone on the back of this guy. So let's power down. We're going to power down. We're going to power down. And I'm going to show you guys the short here, and we're going to try to break it, and we're going to try to isolate that again. This was heavily corroded, and it's funny, my lovely assistant, I told her what it was, and she said, oh, when she helped me put the sockets in, I had I rebuilt the pad for this because she remembered pin 12 of this being a problem. 14, 13. So look, let's get on the meter here. We're between pin 11 and 12, the output of one set of gates into the input of the next set of gates, and it shorted. Right there's the problem. So let's flip this around now. We're going to flip this guy around. I already have him marked out. I don't know if you can zoom in here where the two little dots are. Yep. That bottom one, the pads were gone on this. This was so heavily corroded. And how I use this little wire like this, I'll show you. I'll show you how I rebuild them. So I just use this little wire. I don't know what gauge it is. I just pick it up down at the hardware. And I make like a little tang. If the pad is gone, I'll stick this down in the board about the thickness of the board, and I'll start wrapping it around the leg with tweezers until it's about the size of a pad, and then I just solder it. So I'm thinking I just pushed this wire in too far, and it got into that next trace next to it. But let's desolder. Let me desolder number 12 first, because I think that's the problem. 4, 3, 2. Let's get this one. I probably will find that little piece of wire. Yeah, I see it. Even though without my glasses, I see it. Oh yeah. Okay, I see that. I see that wire in there. You can see that. Oh. Okay, watch out, lovely assistant, for my gun is hot. Okay, bring her back in here. Let's see if we can't fish that guy out. Oh yeah, I see it. It's right here. I want to try to pull that guy out. I think I'm going to have to put here. We're going to have to hit that again. We're going to take 11 and 12. We're going to clean both of those holes. I think both of those were actually reworked. So let's just add some solder to those guys, because there's wire shoved down in there. So get some solder, and I want to get that wire out with it. Yep, I just got it jousted in there too far. Let's try to clean those again. Oh, yeah, great. I really don't think we have to take that whole socket out, but well, let's flip it. I don't know, maybe just getting rid of that solder. Might got rid of that short. Might have gotten rid of it. 3, 2, and what's the meter say? Nope. Nope, that short is still there. All right, let me let's flip this over and take a good look at it here. Yep, I'm just gonna let the video run because I think we're gonna break this board down into 2 videos. So this was getting long enough for me too. So I might have to take that socket out. Let me pull this down, lovely assistant, and check that out. Oh, maybe I can get the maybe I can fish that one piece of wire out. I see it here. I think I got some of it. It might be broken there. We might have to take. Ooh, we might have to take that whole. We might have to take that whole socket out. Yeah, this guy. I don't think I'm ever gonna. I'm gonna try to hit him one more time, and if it don't take care of that short, we're gonna take that whole socket out and just see what's going on. I'm gonna hit them both, yeah, for being replaced. I think that wire I put down in there, it takes up all the room. Yep. All right, let me pull this down a little. I don't think I can. Oh! Well, you can switch it back right here. I must edit the video now, my lovely assistant says. We'll see. You never know, honey. You might get a few new subscribers if they see my pretty assistant. Yeah, that guy is, yeah, my little makeshift pad kind of wants to come out, but it would probably be easier if you know what we could do? I don't know. Let's check and see if that final hit took care of that short. I don't think it did, but let's look. 2, 2, 2, 3, 2, 1. Nope, it's still there. So, okay, guys, we are gonna just we're filming. I can fast forward. I have to edit my pretty assistant out anyway, so she thanks. Oh. Skip those. Those are already broke free. Ugh, it sounds like a sick cow. Wait. Okay. Watch yourself there. Love the assistant. Let's see if we can get that guy out. Yeah. Yep, it's kind of sticky over on that side. Probably because of that short. Okay, lovely assistant. There you go. Let me get the heat back in there. We'll get this guy right off. Probably this one. Yep. Okay, let's have a look. What's going on here? Oh yeah, I think I see it. Yeah, it looks. Yeah, my little jumper wire, I stuck it in way too far. You can see it. It's I'm laughing at myself right here. Look at that. the hell happened there, Keith? Got a little rambunctious with your 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 solder side wire there. It's gone now, so I'm gonna pause there, get that cleaned up, and we'll get here. I'll take over. We're gonna cut that here. I'm gonna clean that guy up under the scope a little bit. I think I got it right there. Here you go. Let me have a look at that guy. I got it. Oh man, that's funny. I'm gonna probably cut that off and freaking use it. I'm just gonna cut that flush right there. I don't know why the heck I have that much sticking up in there. There's that socket. I think we're gonna put that dude right back in. I think it's fixed. Yep. I could have caught that earlier if I would have done a continuity check. I don't know why I didn't really. I thought about it kind of, but I didn't. And now it makes sense why that thing didn't have any sync. All right. Okay, that will hold just like that. Let me get it tacked in. Yeah, I guess we're just going to end this off with the repair. Let me get that tacked in. I think we can solder that in. I think we can solder that dude in. Let's get it tacked in there. Push it in flush. Make sure it's flush. I think it is. Nope, now it is. All right, let me position that thing down. We'll solder that dude in. We'll check for that short, and I think that will be fixed. All right. Let me get these guys in. Oh, I'm going to have to rebuild a couple. Let's see. I hate to do that on camera. We're going to have to maybe fix that pad up a little. Yeah. That one right there, we're going to have to build a little pad for it. I'll show you guys real quick how I do it. And I don't know, the experts will say, oh, you're doing it all wrong, but that's how I do it. And this is how I messed it up the first time. So I use my bit of wire here. And my friend likes that copper wire, but if I could get some of that stuff bare and stripped off without any insulation, I think I would like it a lot, but I've tried to dink with it. So all I do, I just make a little tang. Usually that's about how far I stick it down, like that. Just not even the thickness of the board. I have no idea how I had so much up in there. I would love to make that's what she said joke, but it's probably not polite anymore. So. And I usually, that little tang keeps your wire from spinning. And I'll come in, it's about the same size as the pad that, was corroded off and destroyed during maintenance. But then I just come in here, kind of give it some down. Whoop, like that. Look how, and look how nice. It looks like a normal pad. And I just wiggle that dude around. Watch the short still be there. Let's flip that thing over and check that short. I think we got it though. I had tons of wire stuck up in there. Yep, check out the meter. Open. Boom. That's it. That's it, guys. Right there. Little rework of the rework. Little rework of the rework. You can feel me saying goodbye here. I think I'm going to end the video here. Well, I guess we could turn this back on. Let's turn it back on. I guess we have to verify it if I can find the 04. there. Let's put this 04 back in. Let's put the legs back down. We'll look at Excite Bike Run together. My favorite testing game, apparently. Oh, and look at that. Even my lovely assistant, she's hitting me in the back of the head. Yes. I'm going to get my finger smacked at the end of the episode for that. Ooh, I need it. Okay. There we go. Excite Bike. So that was a very long troubleshooting, some stuff. But, you know, we learned a lot, I think, about the video section. And, you know, if go with your feeling, like, that was my feeling. Like, we lost sync right there at that gate inverter. And I thought that transistor was bad, that it was just getting pulled down, like that whole circuit was getting pulled down. But it wasn't. So, thanks, guys, for watching. Me, Keith, Elder Rock. We'll see you on side B of the same board. Have a great day.